of kinematics. Three particles A, B, C, masses 512 kg, horizontal, A at X, B at Y, C at Z, A towards B 6 meters per second, B is stationary, C moving towards B, so to the left V, and A coalesces with B, they stick together, and then they coalesces with C again, so they stick together again, and they move to the Z's. So show. So the first step here is to use the conservation of momentum. Momentum before equals momentum after. For the momentum before, we use momentum is mass times velocity. Mass A, velocity A, we use plus 6 because it's to the right, and B is stationary, C is moving to the left, so negative. And because they coalesce, they combine, they stick together, we can combine all the masses because they have the same final velocity of the collision. We call it V dash. So use your calculator. This is 30, this is minus 2v, this is 8, and therefore the velocity after they coalesce is this. Proven. Now use kinetic energy, and total loss of kinetic energy 63. So the kinetic energy before is equal to after plus energy lost, because some kinetic energy is converted to heat and sound energy during the collision. So kinetic energy is 1/2 mv squared. Plug in the mass and the velocity. The velocity is 0 here, so this is just 0. And the mass of C, velocity of C, we don't know yet, so we just call it V. And we don't need the plus minus because it is squared anyway, and kinetic energy is scalar, so it's always positive. And for the after collision, we combine the masses because they stick together, and the velocity of the collision is given before, 15 minus v over 4. And now we use a calculator. This is 90, they cancel out, so we have only v squared here, and this is 4, and we square this, so 15 minus v all squared, we get this. 4 squared, we get this. And then we multiply both sides by 4. So 4 times 90 and 4 times v squared, and this term times this cancel out. We have only the numerator, and the second term times this, we get this. And we subtract v squared, so we have 4 minus 1, which is 3. And add 30v to both sides, we have plus 30. And we subtract these two, we get 360 minus 225 minus 252, we get minus 117. Divide both sides by 3, and we factorize. So we have two possible values of v. We use the positive because v is velocity, v is speed, not velocity. V must be positive, so this is rejected. So we have what we need to prove. Now the next part. Given that xy is 36, yz is 98, find the time between the two collisions. So during the first collision, this is stationary, this is going to the right, so the distance traveled is just the distance traveled by A actually, so B is not traveling anywhere, the velocity is 0. So the distance traveled by A is velocity times time, the velocity is 6, the time we call it t1, solve for t1, so this is the time for A to reach B. So the first collision takes 6 seconds after A is moving to the left, to right. And what is the velocity after they combine together? So after they collide here, they combine together, and the velocity is using conservation of momentum. Momentum before, the A is 5 times plus 6, the B stationary, and the combined particle is combined mass times the velocity, so this is 5. So this is the velocity of the combined A and B after the first collision. Now when the A is going to the right to collide with B, actually C is also moving to the left. So during these 6 seconds, C is not here anymore because it is now 6 seconds later, it's around here. To find the distance traveled here, we do velocity times time. The velocity is 3, the time is 6. So C has traveled 18 meters to the left, while A is moving to the right. So, since the total distance is 98, this is 18, the remaining distance here would be 80. So this 80 is the total distance traveled by the combined particle AB and C. So this is the distance traveled by the combined AB, distance traveled by C. The total is supposed to be 80. So that's what we're doing here. So now we need to find the time. Velocity of AB, it's 5, and velocity of C is 3. So this T2 would be the time for this AB to go here and this C to go here when they collide for the second collision. Right, so the time between the first collision and the second collision is 10 seconds. Now the time between A projected, E reaches Z. So E is the combined A, B, C particles. Now, remember that it takes 10 seconds for the combined AB to go to the right and the C to go to the left here to meet for the second collision. So previously we know that C is moving to the left 6 seconds. So during the first 6 seconds when they combine, C is moving here, and then it's still moving to the left again for 10 seconds before it collides with AB. So in total, 10 plus 16, C is moving 16 seconds to the left before it combines with AB. So in that 16 seconds, it has traveled 16 times 3, 48 meters. So it is 48 meters from the right when all three particles combine and coalesce. So now this coalesced particle is now moving to the right. This is the velocity traveling this distance. The time is distance divided by velocity, which is 16 seconds. So this 16 seconds is the time for the coalesced ABC particle, the E, to move to Z. So in total, the time taken for A, since A is moving here, so 6 for the first collision when the A is moving to the B, 10, that is when the combined AB meets C around here, and 16 is the time for the combined ABC to move here. So in total 32 seconds.